How do? Right, this little project is a bit of a part 2 of a part 1. So, as you guys remember before, I made myself a nice little garage heater run from a night heater from a diesel heater. Well, this one is Mark II. This is a little upgraded version, and not only does it heat the workshop as the other one did, it also heats water. Eventually I want to have a little sink in here with hot water, so I can wash parts and other bits and bobs and wash PVA glue off the bottom of 3D prints, so on and so forth. But I don't really want to plumb it into the mains in the garage, so I'm not going to bother. So I'll make myself a water heater using the hot air from the heater. And this is what I come up with. So this is 2.0. What we have here is we have the standard diesel Chinese heater that we got off eBay for about 90 quid. Normally that was connected to the pipes going out to the rest. But I have added these two here. These little things here are two Amazon £10 heat exchangers. All they are, nothing special. The only thing that I've had to physically do myself is 3D print two flat brackets, one to go on each side to go out to the 75mm pipes, and some clips up here, and there's one on the other side here to hold them together. Right, let me quickly show you what's on the back before we jump into firing it up and showing you what's on the front. So on the back we have our main power supply, which is a 30 amp 240 in and 12 out. You need the high amperage to run the heater, and we've got 240 in, and then which goes to the main two switches on the front, which relays to everything else. You've got a pump, which is an Amazon pump, 12 volt, 5 amp, 4 litres a minute, 100 psi, so nice decent high pressure one. It was just one I had in my garage. This is the back of the temperature controller, and this is just a cable from the heater. All the main cables from the heaters. This one goes down to the diesel pump, and then you got your cold air in and exhaust out, and then this is one of the pipes that goes up to the front. Right, so now you've had a look at the back, flick the two switches on the front, which then turns on these two. So we have the heater and the water thermostat. So when I flick this on, as usual, this will get nice and hot. The air will come straight through here and straight out the bottom. When I activate the water temperature sensor and I put it to a certain temperature I want the water to sit at, under here, if you can see, is a magnetic solenoid. So when the water temperature in here, which is powered by a little thermostat coupler that goes all the way down into the water, which is now sitting at 14 degrees, don't know if you can see that, but if I put the standing temperature up to what I want it on, it closes the valve from here to this position, which then lets the air to blow through here and start to heat the water up. And as you can see, the pump's already kicked in and it's pumping the water around nicely. Right, so the water's at 14 degrees. I'll fire the heater up. We'll get that fired up. I'll let it do a cycle for a bit, let it get nice and warm, and then I'll come back to you. Right, so she's all powered up, full capacity, nice and hot. So what I'll do now is I'll go over to this and I'll set the temperature, which is on 8 degrees, the water's 14 degrees. So let's set it up to 40 degree water, shall we? There you go, so 40 degrees on the water. As you can see, the water's now being pumped around. It's going through these two. So once this gets turned on, it then pushes that magnetic solenoid, which is connected to the valve in here, and the valve in here is now opened, so we get hot air out of here still. We also get hot air out of here as well still. So that's pushing out, heating the water as it goes round, and it's still heating the workshop. So what I'll do is I'll let that heat up for a bit, and then I'll come back when it's warm. Right, so I was going to do to 40, but I can't be asked around to wait for that long. So there you go. Just went above 30, automatically shut itself off, which then automatically closes that valve shut again. So then all air comes out the bottom. Nothing's going through this anymore. No water's getting overheated. Nothing's going to get too hot. Nothing's going to melt. It diverts all the hot air out of here, keeping everything safe. Nothing gets buggered. It's took 26 minutes to get that water, which is 10 litres, to 30 degrees. As far as I'm concerned, that's pretty good, being it's a homemade unit. The only issue I had was the valve. I printed one out of ABS and all this heat-proof plastic, and it still melted because it gets incredibly hot in there. So I decided to go with a stainless steel one. But then that changed the capability of what electronics I could use to open and close the valve. I tried little electric ones, I tried little flick bits, I tried servos, and they just weren't man enough to flick that big stainless steel valve. I ended up going with the electromagnetic one. The only issue with that is when they're running for long periods of time, they get warm. Hence the little cooling fan underneath to keep the temperature at a reasonable. It gets warm to touch, but it doesn't get hot that I'm going to be risking anything of fires. Is it practical? No. Is it cool? Yes! You can buy systems like this online, but they're going to set you back probably about £400 to £500. Granted, I already had the heater and the pump was from a previous project, but all in all the parts I spent was about 50 quid. I can't whinge at that. Right, that's me done for this one. Any questions, feel free to drop a comment in and I'll get back to them as quick as I can. The next project I'm working on is I'm going to try and turn the garage completely off the grid. With the electricity prices rising, I ain't got much of a choice, to be fair. So I'm already got a project running at the minute, which is a wind power trickle charger, and I'm going to have a battery bank system to try and run everything off battery. So make sure you subscribe so you can catch me updates on that one, and I'll see you next time.